Something I see very lacking in software development is an understanding of what testing really is. And I really think it got lost at the very beginning. Let me explain. Testing in the context of engineering really started way back before software. So in those days, if you were engineering and developing something, manufacturing something, only after it was produced would you then be able to do some sort of tests against it. And a lot of times the testing would be using the product or using the machinery, living in the building and figuring out what works and what doesn't work, what's failing, what's risky. Some things you could kind of determine ahead of time, other things you couldn't. And then when you were writing the specifications and the requirements, you would have people who have used those types of things in the past, the machinery or the buildings, and help you gain insight as you're writing the requirements, what's really going to work, what's not going to work. So you'd have meetings about the requirements and the detailed specifications and the blueprints and all those things before anybody really started building it. You want to make sure you got everything down to a gnat's eyebrow, because once you have put everything together to try to construct something, to then make any kind of changes afterwards is very expensive, much more cheap to just kind of change some of the requirements. We carried some of that into software. I don't know if it was intentional or not, but we did. Software is something you can change very easily, very quickly. If you're methodical and careful about how you develop the software in the first place, making changes to it is relatively inexpensive compared to tangible things that you might engineer and construct. So in software, we ended up with the same kind of behavior. We would design and develop these very elaborate and detailed and complex things, like an operating system. My first job was as an applications compatibility tester for Windows 95. And really, they took that approach. The developers would develop everything they could in that. And then as testers, our job was to just use that operating system in every possible way we could and try to shake out of it what isn't working well, what's going to break things, what's going to cause problems. And the developers would take time to fix it. And even though those developers making those changes was relatively cheap compared to developing tangible assets, it would cost them great number of man hours to fix things and then for us to retest it and make sure they got it right. And that became the norm for software. Testers were primarily the people that would be there during requirements to try to give guidance, but then really depended on to make sure that they made sure the product that was produced was quality. They used inspection, if you will. They inspected the product after it was developed. In a lot of ways, that's how we do it today. We have automated the inspection. We have improved that to a certain extent, but still our focus is on testing in a way to make sure that the software was created right, instead of using the testing to create it right in the first place, which is kind of what Edwards Deming was talking about when he was talking about manufacturing of tangible assets, but it fits even better for software. And it's what continuous delivery is really all about, and especially the new term built-in quality software development. That is all about using the testing to develop right in the first place. But before we could do that testing well, we need to understand testing itself. And I think that's where we've broke things probably from the very beginning, is not really understanding testing well enough to do it well in software. So let's talk about that for a moment. Testing covers all industries and all different aspects of life. We're going to pick a couple of them for different reasons. Let's say pharmaceuticals. Now, I'm, by the way, generalizing things and talking at a very high level when I discuss these things, and so somebody could probably easily correct anything I say here. But as far as I understand in pharmaceuticals, you have a drug that you're going to test. So that is the test. The thing that you're going to test is the effectiveness of the drug. When someone takes the drug per the prescription, and that would be the action or the event, when they take that drug during the test period, then we're going to validate or examine or kind of observe and watch the test subject, which is the person. Okay, we're testing the drug, but the person is our test subject. They're the one we're watching and observing, we're making changes for. And then we're going to, maybe for certain people that are part of the drug test, we're going to change the dosage a little bit, or the frequency, or we're going to, kind of dial things a little bit. That would be the test data. That's the scenario. So the scenario is like the prescription amount, the frequency, and the thing we're testing is the drug itself. And then the test subject is where we're observing the effect of those different prescriptions on that person. You'd also have as your test data too, by the way, the state of the subject. And so the state of the subject would also play into that. Do they have certain illnesses or tendencies, blood pressure issues, all kinds of stuff like that, diabetes, whatever might be factors of that individual? How does this drug interact with that? Do they need to change things for people that are in that type of situation? So different terminologies. You can kind of see how already that kind of maps a bit toward software if you rethink how we do software in a little bit to align with that. Let's talk about crash testing of a vehicle. We may have airbags in our vehicles, safety harnesses, seat belts, and such. All kinds of safety features in the vehicle for if we have a crash, crumple zones, all kinds of stuff like that. Now, the manufacturer of the airbag will have tests specific to detailed requirements of that airbag, very, very specific things. And so each requirement probably has a specific test they're going to run for that airbag. Same thing for the seat belts, the crumple zones, all that kind of thing. When we put it all into the vehicle, and we test to make sure now the vehicle with all of these things in there is working well, we're not going to pay attention to all of those detailed tests, those component tests of the airbag and component tests of the crumple zones. We're going to have as our test subject the test dummy. Okay, we are testing the safety features of the vehicle, but the dummy is our test subject. That is what we're going to observe or validate at the end of whatever test we run. And as part of that validation, we're going to take a look at different sensors that are on the dummy. We're not going to have like one sensor on the head of the dummy and do a crash and then check that and then crash it again for another sensor and crash it again for yet another sensor. We're going to put all the sensors on the dummy, G-force sensors and impact sensors, all kinds of stuff like that. We're going to crash that vehicle and we're going to examine the dummy to see how effective the equipment was. We're testing the equipment. We're testing the vehicle, but the test subject is our test dummy. Now, when we do that, we're not going to have a separate individual test for whether the head sustained the crash correctly. We're not going to do one test for the airbag and one test for the crumple zones. We're going to crash that car, one test to cover all those requirements. In software, too often what we do is we expect one test per requirement. Again, that fit for the airbag, that fit for testing the seatbelt, that fit for the crumple zone designers. That does not fit for testing the whole vehicle crashing. So we do not, when we're doing crash testing, we do not have one test for each of the requirements. We have one test. And that test will provide verifications for any number of requirements. And how are we going to know that? We validate the test dummy. We're going to check him out, make sure all that stuff resulted in all the requirements being met for the safety of that test dummy in a crash. Okay. And then we have different scenarios we might use. We might have just a single passenger in that vehicle. We might have a single driver, just a driver. Then we might have a front seat adult passenger, a back seat adult passenger. Maybe we have a child in the back seat, rear facing, forward facing. We have a child in the front seat. We have children of different sizes. We have infants. We have, a packed car, an extra person without a seatbelt. I don't know. You can see where I'm going. Those are different scenarios in which you are running the same test. And the test is, for instance, head-on collision. You might have another test that's a side collision. In that side collision, you're still going to have all the same sensors on the dummies, and you'll have sometimes the same scenarios, different passengers in the vehicle, same scenario for the head-on and the side collision, but it's just different scenarios, different tests, same scenarios, okay? So you can see where this comes into software. Today in our industry, We don't test in general, by the way. Some of you might be doing differently, but in general, we don't do it that way. We test in a way that if we were to do it this way in any other industry, we would lose our jobs. Our company may go under. We'd be laughed out of the industry if we tested in tangible construction and design and development. If we did it this way in those industries, we would lose our jobs. But we do it in software, and we think it's the right thing to do, and we support it, and everybody has huge organizations, and to be honest, dumping millions and billions of dollars down the toilet, testing in a way that just doesn't make sense in any other industry. So we need to rethink that. We need to start thinking differently about how we do that. Designing validators that will go through all sorts of detailed verifications no matter what test was run. One validator, one thing that every time you run a test, and you're going to validate that test dummy or that one thing that is your test subject, it's going to run through all the same verifications, every single time, no matter which test you're running. If that's your test dummy, if that's your test subject, those are the verifications you're going to run. We need to change our thinking on that. We need to think of a test as being the action or event that occurs. The path you take, the exact action or event, especially that you do on a web page, on a web service, that action, that's your test. And then think of the different, what we would think of as scenarios to be just the different data or system states that are involved. You change those all you want, but the action or event is still the same. If we break them up that way, our test code becomes so much more simple. We have a lot fewer tests in our library, but greater comprehensive verification of things. And it takes a lot fewer people to maintain that. In fact, a lot of times developers are much more interested in getting involved with automated testing that looks simple like that and easy to, plug and play the parts than the testing that we do right now. It also generates a lot better reporting. You can get really good reporting out of a setup like that. System coverage and requirements coverage right out of the automated testing rather than having to do some type of static analysis or some third-party dependencies where you're trying to publish out the results from your automation to some tool that tries to handle the reporting and something gets fumbled along the way. So just some thoughts on ways that we need to rethink how we go about testing and catch up a little bit to where things are today and get ahead of this move that we're hoping the industry makes to what we call built-in quality. Building it right in the first place, using the testing to build it right in the first place, still have the inspection, but we don't depend on it as heavily. That's our goal.